Shakespeare so famously wrote the line, "What's in a name? That which we call a rose by any other name would smell less sweet." How true that statement holds in today's consumer-driven society. Despite the countless perfume brands and labels, rose oil is still perhaps the most widely used essential oil in perfumery. Essential oils are naturally occurring compounds found in a variety of plant life. What they are perhaps best known for is the aroma they produce. During my research for this project, I ran across many medicinal claims regarding aromatherapy and other medical techniques using essential oils. Although there seems to be evidence that essential oils may indeed have a positive health effect and help with minor ailments like stress, anxiety, and insomnia, and have a topical antibacterial effect, I personally found that some of the claims were not supported by enough data or were overstated and exaggerated. Aromatherapy is a form of alternative medicine. I will let Tim Mitchin sum up my feelings about this.
By definition, I begin, alternative medicine, I continue, has either not been proved to work or been proved not to work. Do you know what they call alternative medicine that's been proved to work? Medicine.
I will leave it at that and let the individual determine what is best for them. I will simply say, ask for evidence when evaluating any medical claim. Before beginning our project, we researched what we thought were the most likely compounds in rose oil. However, each rose species is different and could contain dozens of different compounds in different quantities. Our goal, to isolate and identify the major compounds in our particular species. The most common way essential oils are produced is by a technique known as steam distillation. Although essential oils normally boil at relatively high temperatures, they are steam volatile, which allows them to be distilled out at much lower temperatures. In preparation for our experiment, we crushed up approximately 30 grams of rose petals and placed them in a 100 milliliter beaker of deionized water. We then placed the rose petal and water mixture into a 3-neck round-bottomed flask along with a spin bar and boiling chips. Connected to one of the necks was a separatory funnel filled with deionized water. It was of key importance that the mixture was kept with enough water in order for the steam distillation to occur correctly. The rest of the setup was basically a simple distillation. We allowed the experiment to run, keeping our eye on water level and distilling rate and adjusting accordingly. We collected our distillate in a 100 milliliter cylinder until we had approximately 80 milliliters. We took the distillate and added a small amount of sodium chloride in order to decrease the solubility of the oil in the aqueous layer. In some cases, an easily extractable layer would form. However, in our case it did not, and it became necessary to perform separation using a separatory funnel. We used ether as our organic solvent and added 5 milliliters into the separatory funnel after each extraction. After mixing and venting, we allowed the layers to form. We then collected and combined the organic layer after each separation respectively, performing the process 3 times. Having collected our organic product, we added anhydrous sodium sulfate in order to remove any remaining water. The final step in the isolation of the rose oil was to remove the remaining ether from the oil. This was easily accomplished with a quick dip in a hot water bath. The ether quickly evaporated out, leaving us with a small golden hue amount of rose oil. And immediately we began to smell a strong, somewhat pleasant odor.
We initially began with 30 grams of rose petals. From that, we were able to extract 0.05 grams of rose oil. The next step we performed was IR analysis. Our results demonstrated a diagnostic peak at 3,405.67 centimeters to the -1 that corresponds with the presence of an OH group. This gave us an indication that we properly extracted the main components of rose oil because they contain OH. Although IR indicates the presence of the OH group, it does not indicate the quantity of alcohols present in the rose oil or the specific alcohols present. The next form of analysis we performed was gas chromatography. Initially, we ran our rose oil sample in hexanes and our standards in acetone. This produced a shifted graph which we corrected by running the sample and standards in acetone. Furthermore, we also slowed down the rate. The standards we ran were geraniol, citronellol, limonene, and alpha-pinene. The GC indicated that our sample contained 56.36% geraniol, 9.25% citronellol, 4.94% limonene. (29.45% rose oxide). Although we did not run a standard for rose oxide, we determined through the boiling points of our known standards that rose oxide was the most plausible compound. The boiling point of rose oxide is lower than both geraniol and citronellol and higher than limonene. We were unable to perform a refractive index analysis because we ran out of sample.
Thank you for watching, and I hope you found this video both educational and entertaining. I have found that a scientific understanding of the natural world helps you better appreciate its beauty and elegance. I hope the next time you're walking through a garden, you take a second to stop and smell the roses.